48 ready-to-fire missiles stacked on a single mobile combat vehicle is an impossible number that breaks every rule of traditional air defense. In late 2023 and throughout 2024, Russia's early-generation short-range air defense platforms found themselves completely exposed and vulnerable on the modern battlefield. Millions of dollars in advanced military hardware became defenseless against swarms of cheap kamikaze drones and precision-guided rockets because traditional launch vehicles simply ran out of ammunition in minutes, leaving entire armored columns useless and open to destruction. This critical tactical crisis pushed state defense planners to the edge, forcing a radical engineering breakthrough to survive. How can a single mobile platform pack enough firepower to neutralize an entire incoming swarm without constantly retreating to reload? The answer arrived in early 2026, when global defense networks confirmed the combat deployment of Russia's Pantsir SMSV near the Kursk border region. On paper, leading global defense analysts argue that this tracked behemoth represents the ultimate tactical salvation for frontline troops. While a standard United States MIM104 Patriot launcher typically carries between 4 and 16 missiles, and the Israeli Iron Dome relies on heavy stationary batteries to hold 20 interceptors, the new tracked Pantsir SMSV changes the paradigm completely by carrying a staggering 48 missiles. This is no longer a slow logistical resupply vehicle, but a fast, highly maneuverable frontline shield capable of operating directly in the mud and snow alongside main battle tanks. This massive firepower upgrade aims to permanently break the economic math of modern attrition warfare. Before we go on, do you think this massive missile upgrade will permanently change the battlefield, or is it just a temporary fix? Subscribe to the channel to catch our next deep dive, and tell me where you're watching from. The engineering magic behind this massive payload relies on a revolutionary modular design known as the Quadpack system. To achieve this breakthrough, designers at the KBP Instrument Design Bureau chose not to build a larger, more cumbersome vehicle. Instead, they completely re-engineered the interceptor technology itself. A standard launch container that previously held just one long-range missile can now be fitted with a specialized 4-cell matrix containing the newly developed TKB-1055 lightweight mini-missiles, also designated as the 19Y6. This modular flexibility means the vehicle can carry a full complement of 48 mini-missiles, or mix them with heavy supersonic interceptors, depending on the threat matrix. On the battlefield, this design directly addresses the saturation tactics utilized by modern militaries. When a swarm of 20 to 30 low-cost kamikaze drones attacks simultaneously, older defense systems are quickly depleted and forced to retreat for a time-consuming reload process. The Quadpack configuration alters this dangerous dynamic entirely. This platform can stand its ground and engage dozens of low-altitude targets sequentially, without exhausting its immediate magazine. Furthermore, these mini-missiles are highly cost-effective, allowing defense forces to intercept a $500 drone without wasting a standard $150,000 missile. For longer-range threats, the platform utilizes the advanced 95Y6M supersonic interceptor. This larger missile reaches blistering speeds between Mach 5.5 and Mach 6, which is approximately 1,800 meters per second. This extreme velocity extends the engagement envelope out to 40 kilometers, with an operational altitude ceiling of 18 kilometers, giving enemy aircraft and precision-guided munitions almost zero reaction time. By pairing these high-speed interceptors with a high-volume matrix of cheap mini-missiles, the system successfully establishes a multi-tiered defensive shield capable of turning the economic calculus of modern attrition warfare upside down. However, a massive magazine of 48 missiles is completely useless without the proper legs to carry the weight and a powerful eye to guide them to their targets. In the muddy terrain of Eastern Europe, during the rainy seasons of 2022 and 2023, the older wheeled cam AZ truck chassis of the Pantsir S1 encountered severe operational limitations. Its high center of gravity made it prone to overturning during high-speed maneuvers, and it frequently became immobilized in deep mud, leaving advanced armored formations completely exposed without immediate short-range air defense protection. To solve this critical vulnerability, the new Pantsir SMSV undergoes a major structural transformation by adopting the GM 352M1E tracked combat chassis. Powered by a heavy 840 horsepower multi-fuel diesel engine, this armored tracked platform achieves a maximum speed of 70 kilometers per hour on both roads and rough terrain. More importantly, this tracked configuration distributes the heavy weight of the vehicle evenly, allowing the platform to maintain identical cross-country mobility with main battle tanks like the T-90M and infantry fighting vehicles like the BMP-3, delivering continuous air defense right on the front line. To maximize the effectiveness of this heavy armament, the vehicle integrates a completely new active electronically scanned array radar system. This state-of-the-art radar sensor increases the target detection range from 36 kilometers up to 75 kilometers. It possesses the advanced capability to track and lock onto low observable targets with a radar cross-section of just 1 square meter at a distance of 60 kilometers. By combining this high-mobility tracked chassis with the long-range tracking capability of the Active Electronically Scanned Array radar, the platform ensures that the 48 onboard missiles receive precise target coordinates early, optimizing the interception window against multiple incoming low-altitude threats. While the integration of 48 missiles on a single track chassis offers incredible firepower, global defense networks point out that this layout is not entirely invincible due to inherent technical blind spots. In February 2026, the basic technology behind this platform was presented to international buyers at the World Defense Show in Saudi Arabia, demonstrating how short-range air defense platforms are pivoting toward anti-drone operations. However, leading electronic warfare experts emphasize that the platform does not utilize fire-and-forget missiles. Instead, the mini-missiles rely on a radio command guidance system, meaning the vehicle must continuously transmit guidance signals to the interceptors until the exact moment of impact. The primary fire control radar on the Pantsir SMSV can only guide up to 4 missiles toward 4 distinct targets simultaneously. Consequently, if an adversary coordinates a massive saturation strike with 5 or 6 separate attack vectors at the exact same second, this heavy magazine vehicle still faces the dangerous risk of system saturation before discharging its remaining ammunition. Furthermore, maintaining the serial production of advanced active electronically scanned array radars remains a substantial logistical challenge due to international restrictions on complex semiconductor components like gallium nitride modules. Ultimately, the profound lesson of this modern military hardware is that victory on the contemporary battlefield is no longer determined solely by the most powerful weapon, but by the most economically sustainable one. By packing dozens of affordable interceptors into a single highly mobile frontline asset, this vehicle successfully forces traditional militaries to completely rethink the cost of attrition in mechanized warfare. Do you believe this heavy reliance on large missile numbers on a single vehicle will become the global standard for short-range air defense? Or will decentralized platforms eventually prove more resilient against modern saturation tactics?